Hello, everyone, and welcome back to your channel of probability and statistics. In today's session, we are going to continue with our studio, and I want to show you how we can construct our own t-test to find, for test of hypotheses. Oops, sorry, what happened? Okay, so in this problem, I got a problem that says we were trying to find out the contaminants in water to make sure it's potable. So in micrograms per liter. So we selected 12 water specimens, and I have the numbers. So I'm going to enter these numbers. The way we enter them, I want to enter them as a vector. Okay. And the way we do it, the easiest way to do it in our studio is to create a variable. Let's call it, I'm going to call it my data or example or whatever. I prefer to use my data. It doesn't have to be capital. Let's make it lowercase. It's easier. Equals. And then the way we construct a vector, the easiest way is to use the letter C for combine the following numbers, okay? I have 2.4, the first specimen. The second is 2.9. The third is 2.7, 2.6, then 2.9, then 2, then 2.8, then 2.2, then 2.4 twice, then 2, then 2.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, they are 12. We don't care because, of course, the software will calculate that for us. Okay, that's all what I have. Oh, and we want to check whether the water contaminants is greater than 2.25. So, right, I'm going to say mu equals 2.25. Notice we don't say greater than, that's the null hypothesis. It's just mu equals 2.25. In order to check, and they said the data is normally distributed and they want to check, they didn't specify, so we are going to say alpha is 0.05. Okay, so now I need to find all the ingredients, right? We need to find t-calc, and t-calc is x bar minus mu over s over root n. So I need x bar, I need s, and I need n. Okay, of course I entered 12 values, so I can say n equals 12. That's not a good practice because later if I delete one point or add another point and I forget to correct n and I use 12, it won't be correct. So try always to use variables, not numeric values. So for example, here I'm going to say x bar. So let's call it x bar. X bar is the mean of my data. That's it. It will store it. If you want to see it on the screen, you can say X bar. So it will print it out for you. You don't have to. Okay. Also, it's a good practice to add comments. I don't do that because of waste of time, but I can use a hashtag, and the hashtag is saying that to tell the program that everything in green in this line, just forget it. Don't worry about it. Skip it. But for us, it gives us an information for the reader. If I say my data equal that, mu equals that, I don't understand what you're doing. But you can say this is a hypothesis testing problem, for example. So when you come back and you see my data, you know what you're doing. And this is for example, I can add here the null hypothesis. And I can read the null hypothesis mu equals 2.25 and stuff like that. Okay, I can print I need the standard deviation. I already have x bar and mu. That's the numerator. I still need s So S equals standard deviation is SD. So SD of my data, and you can use the tab so you don't have to type everything. And I can print S if I want. Maybe I want N. I'm not going to say N equals 12. I'm going to say N equals the length of my vector, the length of my data. Again, tab to get the thing, and then I can print N, which I don't care about. And now I can calculate t-calc. So I can say t-calc equals, between parentheses, x bar minus mu divided by s over the square root of n. You see, I didn't need to write numbers. It will be stored for me. I can print it on the screen again. I don't need to, but I can do it. Now, I want to find the rejection region. I'm going to reject anything above 95%, right? Because that would be the worst. I want the contaminants to be as small as possible. Negative infinity is the optimal, which will never happen, right? You cannot have negative contaminants. But theoretically speaking, that's the 100th percentile, 90th, 80th, whatever. The 5th percentile, anything below that will be rejected, correct? So I'm going to say, I want to find the 95th cumulative distribution. Notice in statistics, we say it's t.05, but when I calculate cumulative, it would be 0.95. You have to be careful about these things. So I'm going to say upper limit, for example, equals qt, meaning the inverse t of 0.95 and n minus 1 degrees of freedom. Or, in fact, since I didn't type alpha, if I had said alpha equals 0.05, I can say this is 1 minus alpha and degrees of freedom. So I don't use numbers at all in my function, right? Now, I can check, I want to check to see if t-calc is higher than this or no. And if it's higher, I wanted to say reject. If it's not higher, I would say fail to reject. Do you remember the if statement, if else? If t-calc is higher than ul, enter reject, else enter fail to reject. You can do that in a single line, as RStudio and many other language provides you with something called if else, so that you can enter the whole thing in one line. So you can say if else t-calc is greater than ul, what do you want me to enter? Reject. Else, fail to reject. So I can store text, and then I'm going to call that test, for example. Okay, I could call it whatever. And now I finished the work. See, it wasn't that bad. In fact, I kept typing n and t. I don't need to do those. It's just few lines. I calculated the mean, the standard deviation, n, and then t-calc, upper limit, and test. It's like 5 or 6 lines. It's not that bad. Then I'm going to type the statement. I want to show the statement. So the way we do that, the easiest way without formatting, without anything, is to use what we call cat for concatenate things. I can concatenate numbers and text. So the text, for example, I can say between, notice if it's a text, you have to include quotation like here. So I would say conclusion. No, I want to enter my conclusion. Oops, conclusion. And then I say test. So my conclusion is either reject or fail to reject, right? The null hypothesis, and you can keep writing that the contaminants uh, into water is 2.25 microgram per liter, or if you want, right? Um, at 0.05 level of significance. That's it. Maybe the only thing I didn't show is the p-value, right? Sometimes you may need the p-value, so you can say p-val equals. I want to find anything above my t-calc, right? The area to the right of t-calc is the p-value. But here, if I want to use cumulative, then I would say p-value equals pt of negative t-calc. Of course, the t-calc would be positive, right? Because I'm checking if it's greater than something. If you are not even, suppose this was a two-sided test, but if it's a two-sided test, the p-value would be multiplied by 2. This quantity would be multiplied by 2. But to guarantee that what you are doing is correct, you have to say, I always tell my students to do that, is to say negative the absolute value of t-calc. Meaning if t-calc is positive, it doesn't it doesn't harm to say absolute value, right? If my t-calc is 1.2, I multiplied by net. But what if my t-calc was negative already and I don't know that? So I to guarantee my value here would be negative is to take the absolute value, make it positive, and then multiply it by negative again. Okay, so it works for both cases. And you have to enter the degrees of freedom and -1. Again, I could have come here and say, I could have said degrees of freedom equals length of my data -1. So instead of finding n and then coming and type here n -1. I didn't do that, but it's okay. Okay, so now I can run this and see what I get. I already created my own t-test, right? Very simple, 6 or 7 lines. And here's what you get. This is the like it's the part that will not be executed in the test, or the null hypothesis. So these are just comments. I enter my data, calculated mu, it turns out, said mu is 2.25, calculated X bar, and it turns out to be 2.48, which is higher than 225. But that's what I expected, of course, to be higher, but we need to know, is it significantly higher or statistically higher at 5% level of significance or no? So we calculate the standard deviation. The n was 12, as we knew. And then my t-calc was 2.58. I didn't show the upper limit. I could have printed the upper limit to check it versus that. So again, we could have done that. Let's say after we calculated this, we can type or show on the screen so we know the answer right away without running, right? So let's see that. See, the upper limit is 1.8, but the t-calc is 2.6, so definitely I would reject. And sure enough, the conclusion that I got, reject the null hypothesis at 0.05 level of signal. Nice, right? I want to draw your attention to something that we haven't discussed. But notice I had the distribution. I was checking anything above a certain value would be rejected, and I rejected, meaning the mean of my sample was higher than the upper limit. It turns out that the hypothesis testing and the confidence interval are two faces of the same coin. Meaning, if I take my average, which is 2.4833. And I constructed a lower bound confidence interval. Why lower bound? Because in the hypothesis testing, I was checking anything above a number. So when I consider the confidence, I said it's the like the two faces of the same coin. So I will look at the lower bound of a 95% confidence interval, and I guarantee you that the lower bound would be higher than 2.25. That's why we rejected the null hypothesis. I'm not going to show it now because, I think it's enough to do that. But you could do it. Uh, you could do it yourself. In fact, now you have all the ingredients to find a lower limit at qt 0.05 and n minus 1 and construct a confidence interval. However, remember I talked about the stats package? I think it comes with our studio, but even if it didn't, and I told you how to find it, you enter stat, you type here stats, and if it's not, sorry, of course, I didn't find it. I have it, but if I didn't have it, I can click install. And if I have it, I can click update and see if it needs updates or not. But this stats, it's very nice because it has the t-test already embedded. And the way you check it is to say t.test. Oh, it asks you, what is your x? My x is the value, is the vector of my data. So I will enter my data. It will ask you, what is mu? You say mu, which is mu sub 0, h sub 0 equals 2.25. It should ask you, is that a one-sided, or what is the alternative? So you enter alternative equals, it's greater. So you enter greater. You can enter greater or less or two dot-sided. You have three options. And finally, we don't say alpha, we say the confidence level is 0.95. Confidence level equals 0.95. And you can run only this line, right? By clicking Command Enter. I don't know for what it says there. And guess what? Look at what we got. T is 2.5836. 2.5836. Degrees of freedom is 11. The p-value is 0.01271. I don't think we got the p-value here. We didn't print it out. I didn't print it out. Let's print it out. Yeah, I wanted to do it, but I forgot. So p-value, let's only run this line and see what we get when we did it. Absolutely the same number, 0.012. Oops. You see 0.01271, 0.01271. Alternative hypothesis, the true mean is greater than 2.25. They don't tell you whether to reject or so the confidence interval was from 232,114 to positive infinity, meaning the 2.25 is not in the 95% confidence interval, so you reject. But when we write it, we can make it more clear, right? Remember here, we ended up having the conclusion. I'm sorry, here. I had this line, conclusion, reject the null hypothesis at that. And right after that, we can say, for example, maybe to make it clearer. Okay, when we concatenate that, we can say as the p value was, and then I concatenate. In fact, I can complete on the next line. P val was less than 0.05 or less than alpha. So really, I can run only this line, and you can see here that I I got it written that yeah, I don't need it then the comma here. It doesn't matter. But you see, I reject the null hypothesis at 0.05 level of significance as the p-value was that, uh, which I should say, which is less than 0.05. So you can make it better than what you get from RStudio, especially if you want to save that in a test. So, for example, in a text, in a file. So if this was a homework, every time I all what I need to do is to show the mean, the standard deviation. So I'm gonna send this, the length, the t-calc, and then the test line to a file, and it will show up just the answers. I don't show the code itself. You see, for example, here, I did many stuff for the kids before. These are some examples. Let me show you, for example, one homework assignment, how it turned out, homework solution, for example. So here is the problem. I showed the 95% confidence interval on the variance using chi-square and the standard deviation. The next problem, the data seems to be normally distributed. Part B, that's the upper bound, and so on and so forth. So you only send to the file what what you what you are asked to find. Decision reject the null hypothesis at 0.1 level of significance. Here I calculated beta. Here I got the p-value. So you don't need to show the whole thing. And we'll learn how to write to files later. But at least for now, I want you to understand how we created our uh, uh, t-test. We can also create our own confidence level, either upper or lower. And I think after that, you know, oh, maybe one more thing I wanted to show you. I want to show you that I can, for example, with the oh my God, where is why it's not running? Okay. Okay. Suppose let me delete that for or we can comment it. Okay. It's been a while since I used it. I thought, yeah, we can comment lines. So I'm going to comment everything. So I'm not running this again. And instead of deleting everything, right? And here we can, for example, plot the normal distribution or the exponential distribution like a PDF. Suppose I want to create okay, I'm going to show you the standard normal distribution. Okay. So I'm going to create values of X. You see, the most of the distribution is between -3 and +3, right? So in fact, I can even say -4 to +4. So I'm going to write a sequence, which is another way to create a vector, a sequence from -4 to +4 with increments, very small increments, so maybe 0.001. Okay, so it will calculate what is the PDF at -4 and then -3.99 and then -3.999 and 3.998. It would increment, so it will create like what, 80,000 data points? It doesn't matter. And then for each one of those, it should calculate the D norm of X. If I don't specify the mean and the standard deviation, it's known that the mean is 0 and the standard deviation is 1, which is the standard normal. If I have another normal distribution, for example, I can say mean of 10 and a standard deviation of 3. But if it's 0 and 1, I don't need to type them. They are uh, already there. And then I'm going to plot X and Y. enter X first, then Y. And then there are types. I can plot only points, or I combine them and draw a line, which I need, or I can enter them as a step function. Suppose that was a cumulative distribution function of a binomial or Poisson or geometric, something that is discrete. Then I want to show it as a step function, not a line, right? You see that. So I'm going to say type equals L for line, or O for points, or S for step. And I also can choose a color. So the color, I can do red, blue, green. And the nice thing about the new version of our studio is that it shows you the color on the screen right when you type it. So if I say blue, that's how my graph would look. If I say red, that's how it's going to look. If I said cyan, and so on and so forth. Sometimes it doesn't like to plot something like that. So I will create like a way, or like a screen where, so usually you don't have to worry about that. I'm going to show it to you after that, maybe later. One and one. I just have one row and one column because I have only um, one graph. And now when I run this and look at plots, oh, I never said plot. That's why I didn't get anything. Yeah, I showed you. Oh, no, I said plot. Oh, I didn't select the plot. That's why. See, I'm getting old. Here it is. You can zoom, and it shows you in cyan a normal distribution graph. I can show the t. So, for example, this is, I say dt, but instead of dt of x, I say x with a mean of 0, yes, but the standard deviation, remember, it's, so I say 0, and the standard deviation, remember, is the square root of the degrees of freedom over the degrees of freedom over 2, minus 2. I had 11 degrees of freedom in this problem, so square root of 11 over 9. Oh, no, it didn't show that. dt. So let's say dt only. Let me see how it's gonna look like. But that's not what I want. No, for some reason it's not showing the plots. I don't know what happened. Must have done something weird here. So if I return back and make that the norm, will I get it back? Oh, I think I didn't. Oh my God. I think I ran, or I executed only one line instead of the whole part. I forgot to click. Okay, let me see. Square root of 11 over 9. If I select, no, for some reason, I don't think it's working. Oops. Returning infinity for less. So what if I do just that? Will it show? And let's make this red. It would be clearer, I think. df is missing. Okay. It was 11 degrees of freedom. Okay. So that's why. Yeah. And now you can zoom and get the t. In fact, I can show both the t and the z on top of each other, so you can check them out. In fact, I don't think we deleted. This is the z. and you can see the T. But uh, that's with 11 degrees of freedom. I also could have shown a line showing the upper limit, and the line showing where my T-calc is, and so on and so forth. I think, these are just embellishments, but the most important thing is that you learn how to run the T-test on your own or through t.test from RStudio. I think we'll stop with RStudio for now. We will start doing uh, um, confidence interval and hypothesis testing for two samples from two different populations next, and then we'll come back and see how we run these with RStudio. I hope it wasn't that bad for you today, and I wish you all the best until I see you again. Have a great day.